We all know that drone ship booster landings are the primary reuse method for Falcon 9, and these days it seems like one is happening all the time. The drone ship reuse architecture has been pivotal in SpaceX's reuse model. And yet, for Starship, SpaceX has abandoned the drone ship model and gone solely with the return to launch site model, where the booster will be caught by a large set of arms known as Mechazilla. We know that using return to launch site with Falcon 9 has a significant payload cost, and that should be true for Starship as well. Why would SpaceX stop using drone ships? It just doesn't add up. I hadn't dug deeply into the marine operations side of SpaceX, and after a fair bit of research, I've come to the conclusion that rockets are easy to analyze, and drone ships are very complicated. Or, as Rocket Lab CEO Peter Beck famously said, I can tell you 100% in full honesty, marine assets suck. And initially the plan for Rocket Lab's Neutron rocket was to always do return to launch site, but they have since decided to land downrange on a drone ship. We're going to have to spend a bit of time understanding why Falcon 9 uses drone ship recovery, how it is done, and then we'll talk about why Starship, at least currently, will always fly the booster back to the launch site. For Falcon 9, it all comes down to payload capabilities. One of the main goals of Falcon 9 was to be able to launch communications satellites to geosynchronous transfer orbit. Those payloads are roughly in the 3 to 7 ton range. If we add in the payload capability of Falcon 9 to those orbits, we see that those missions cannot be flown with a return to launch site, and if you want reuse, you need to go with the drone ship. For low Earth orbit launches, the situation is a little better. Crew and cargo Dragon flights are able to sneak in just under the limit, and can fly return to launch site missions, but earlier versions of Falcon 9 had slightly less performance, and SpaceX kept larger performance margins, and therefore the Dragon missions were flown with drone ship recovery. It probably made NASA happier as well. Starlink missions carry enough satellites to be right up at the payload limit for a drone ship landing. Starlink seems like the perfect place to use return to launch site. It would take 7 flights to carry the same number of satellites that could be carried with 5 drone ship launches, but it would be a lot simpler. But those 2 more flights mean 2 more second stages, launch licenses, booster refurbishments, launch pad repairs, and propellant loads. It would also mean, for a given flight rate, about 30% fewer satellites into orbit per month. My guess is that those 2 extra flights, and especially the cost of the 2 extra second stages, means that return to launch site costs a little more, but I think the big driver is the number of satellites per month. To summarize, drone ship landings allowed SpaceX to do 2 important things with Falcon 9. They could hit specific payload targets and launch payloads that they could not carry with return to launch site landings, and they could get the maximum payload out of the second stage that they expend on every flight. But Starship is a different beast. It has sufficient performance to carry all current payloads, and it is fully reusable, so the Falcon 9 second stage concern does not apply. To understand why Starship isn't going to do drone ship landings, we need to understand more about the SpaceX fleet. The SpaceX drone ships in Florida are paired with support vessels that go out to assist and also to retrieve fairings. The support ships are named Bob and Doug after the 2 astronauts who flew the first Crew Dragon mission to the International Space Station, not after Bob and Doug McKenzie from the Great White North. The drone ships have thrusters in all 4 corners that keep them on station so the boosters know where to find them. That is why they are called autonomous drone ships. They can stay where they need to be without people on board. The newest drone ship, a shortfall of Gravitas, has onboard propulsion to take it to the catch location and back, but SpaceX has not used that capability yet. Drone ships therefore need to be towed. They can be towed by either Bob or Doug, but Bob and Doug also have fairing retrieval duties that require them to be in a slightly different position from the drone ship, and each ship can carry 4 fairings, so they will generally stay out for more than 1 mission. That means SpaceX will often pay a tug to carry a drone ship out to the proper location and back to port. And then it's just a matter of setting up a steady cadence for all the ships, and everything runs smoothly. That, of course, is not true, because nothing is simple with marine assets. This graph shows all the drone ship landings for the first half of 2024, after SpaceX has had a few years to tune their system for efficiency. Note that it's not showing the use of the support ships or tugs. The top section shows the drone ship, Of Course I Still Love You, which operates out of Long Beach in California for launches from Vandenberg. Just read the instructions, and a shortfall of Gravitas both operate out of Port Canaveral in Florida. We can figure out a few things. The first is that the shortest turnaround from one landing to the next is 4 days, but those are uncommon, and 5 days between landings tends to be the shortest time. There are also gaps big and small when a drone ship isn't operating at all. Across the fleet, the drone ships average about one landing every 10 days, or about half their maximum rate. Remember what Peter Beck said about marine assets. While it's common for a ship's crew to work a month without a day off, eventually they will need downtime, and that is one factor that leads to the slower rate. And the ship will need downtime to conduct regular maintenance, repairs, and upgrades. And finally, the weather is always a factor. If it's not safe for the drone ship and support ships to be out there, the flight has to be delayed. And even with acceptable conditions, the weather can increase the time to get to the landing point or return to port. Marine assets are also expensive. Bob and Doug probably cost around $10 to $20 million per year each, and the drone ship costs are likely similar, perhaps more because of the need to pay tug companies to move them around. And they cost almost the same tied up to the dock if you aren't flying. Marine assets add a lot of complexity and uncertainty to your life. Now let's talk about Starship. The two big goals for Starship, outside of Starlink launches, are to support NASA's Artemis mission and future Mars exploration. Both of these require what NASA calls propellant aggregation. You need to fly a bunch of missions to carry enough fuel into orbit to refuel the mission's Starship, which means you need to fly often. With that in mind, let's explore what a few different scenarios would mean to Super Heavy. I'm going to assume that Super Heavy has rapid turnaround and can fly once a day. The Falcon 9 drone ship approach can support a flight rate of about once every 10 days. Using Starship 1 numbers, a flight could carry about 50 tons of payload if flown return to launch site. If we add a drone ship to that, my model estimates we can carry about 80 tons of payload. That seems like a no-brainer in terms of payload, but remember that we don't have expendable second stages to deal with, and, assuming Starship works the way it should, our big cost is fuel cost. Having said that, if you're flying once every 10 days, the drone ship is probably a win. But remember that both the Moon and Mars missions need refueling, and you're going to want to do those as quickly as possible. 100 days for 10 flights will not be acceptable, and more than 10 flights might be required. With return to launch site, we can fly a mission every day with a single Super Heavy booster. But the drone ship approach has a problem. At best, they have a cycle time of 5 days, so we need 5 of them to fly once a day, but we might need 10 of them to do this on a sustained basis. 7 is a reasonable minimum if you're very organized, get lucky with the weather, and can accept downtime after a fast surge of missions. We also need more Super Heavy boosters because some of them are stuck on the drone ships coming back, or being transported from the dock to the launch site. I'm going to say you need 4. Flying once a day now requires 4 Super Heavy boosters and 7 drone ship groups, and that's if you get lucky. That payload advantage no longer seems attractive. It's pretty likely you can fly an extra mission a day to exceed the drone ship payload and spend a lot less than those drone ships cost. And you have to purchase those custom drone ships and find a place to store all your vessels because Port Canaveral does not have room. And let's say that you have a refueling mission that can take 2 flights a day, and you have 2 others you need to fly as well, bumping your flight rate to 4 times per day. You need 4 Super Heavies for return to launch site, but you need 16 Super Heavies for the drone ship approach and 28 drone ship groups. The point of these scenarios is pretty simple. Drone ships are fine at low flight rates, but if you want to fly all the time, which is what SpaceX wants to do with Starship, the slow cycle times just kill you. Airlines are masters at high utilization. When the plane lands, it taxis to the gate, then the airline unloads people and cargo, cleans the cabin, loads people, cargo, and fuel, leaves the gate, taxis, and takes off. That time in the middle is known as turnaround time, and airlines work hard to minimize it because they only make money when planes are flying. A good airline will do that in about 60 minutes. Because of this focus, most airlines are working about 11 hours a day, every day. For Falcon 9, the time from liftoff to droneship landing is about 8.5 minutes, then things slow way down. A couple of days to get back to port, 9 days to do refurbishment and inspection is supposedly the fastest they've done, then presumably a couple days to get a new fairing attached, and then you're finally ready to fly. The fastest that SpaceX has ever reflown a booster is 27 days, which they have done twice. What that means is that the return time because of the droneship is a small proportion of the overall cycle time. And SpaceX isn't even trying to minimize that time to refly boosters quickly. The time that boosters spend on the droneships has pretty much zero impact on the overall cycle time. Starship is a different beast. The SpaceX goal is for gas-and-go operation of Super Heavy, with inspection and propellant loading taking place almost immediately after landing. Let's say, for sake of argument, they can do it in 8 hours. You've probably already figured out the issue. That 3 days spent on the droneship is 90% of the time between flights, and because it's transit time, there's very little you can do to reduce it. You can maybe do 4-day cycle times on each booster, if the weather is good, and if you don't have mechanical issues with the marine assets. This is the real reason why Starship uses return to launch site. It's expensive in terms of payload, but it's the only way you can get truly rapid turnaround, and that is required for the Starship missions. What did we learn? Droneships are a necessary evil if you need the extra performance to reach your target market, and as long as your cycle time is less than the cycle time of the droneship. But they have very high fixed costs, and they do not scale well to high flight rates. If you enjoyed this video, please send me this Autel Titan drone.